Next, I want to talk about a type of function called a piecewise-defined function. Let me give you the definition, and we'll look at some examples. A piecewise-defined function is a function that is defined by a different equation for different parts of its domain. We're going to look at two examples here. The first one is just a generic example that I've made up, and the second one is more of a real-world application problem. For our first example, let's take a look at the function f of x, which is defined in the following way. F of x equals 3 for x less than or equal to 0, and f of x equals x squared for x greater than 0. So if we're looking at values of x that are less than or equal to 0, the function value is going to be 3. So for example, f of negative 5 is going to be 3. Also, f of negative 3 is going to be 3. F of negative 1 is 3. And f of 0 is 3. That's because all of these numbers are in this first part of the domain. And for this part of the domain, f of x is always going to be equal to 3. But if we want to look at values of x that are larger than 0, such as 1, 2, or 3, for each of these, we have to use the fact that f of x equals x squared. So if we're looking at this part of the domain, f squares the value of x. So 1 squared is going to be 1, 2 squared is 4, and 3 squared is 9. This gives us a table of values, even though I haven't actually listed it as a table. This gives us several values that we can plot on our xy plane to see what this graph is going to look like. I'm going to start by plotting the points that we got from the first part of the domain. We've got negative 5, 3 first. That's right here. And then negative 3, 3, negative 1, 3, and 0, 3. If we look on this part of the domain, x is less than or equal to 0, we know that this is a constant function, and so we're going to end up with a horizontal ray pointing out to the left. But we can't continue this any further to the right because this is only the graph for x is less than or equal to 0. We've got something else going on for x is greater than 0. So let's plot these points now. First we have 1, 1, and then we've got 2, 4, and then we've got 3, 9. So this part of the graph follows y equals x squared, which we know is a parabola. But it's only going to be the right half of the parabola because this part of the function only exists for x is greater than 0. Now we have to be careful here because this says x is greater than 0, not x is equal to 0. So the point 0, 0 is not actually going to be a part of this graph. We're going to have to put an open circle there because when x is 0, we know that we're in the first part of the graph, and so f of x has to be 3. So we're going to have a closed circle here and an open circle down below. We can't have both of these be closed circles because if that was the case, this would fail the vertical line test. We know that each graph of a function can only have one point on any vertical line, and in this case, it's going to be the point 0, 3, because when x equals 0, we're part of this first domain, and so we know that the y value has to be 3. Oftentimes, when we're dealing with piecewise-defined functions, you're going to have graphs that come in multiple parts, and when you get to the place where those two might line up, you're going to have open circles and closed circles depending on whether or not that point is a part of the graph or not. All right, this is one just generic algebraic example of a piecewise defined function. What I want to do now is I want to talk about a real life example. So let's take a look at it. A cell phone plan costs $30 per month and includes 2 free gigabytes of data. After that, it costs $5 per gigabyte of data. Sketch a graph of the cost function in terms of gigabytes of data used. So first what I want to do is I want to write out the cost function, and we're letting it be a function of x, where x is the amount of data being used per month. Now first we're told that the plan costs $30 per month and includes 2 free gigabytes of data. So it's going to be $30 in total if the amount of data we have is between 0 gigabytes and 2. However, we're going to have a more complicated expression for this function if we're using more data. If we use any additional data, we still have to pay the $30 for the account. But then we have to pay $5 for each additional gigabyte. So if we're given 2 gigabytes to start with, and we use x gigabytes in total, that means that x minus 2 represents the extra data that we're paying for, $5 per gigabyte. So then this is going to be 30 plus 5 times x minus 2 for x greater than 2. This cell phone plan, the cost of which is actually represented by a piecewise defined function. It's a different cost if we're using less than 2 gigabytes of data or more than 2 gigabytes of data. So what I want to do is I want to evaluate this function for certain values so we can make a table of values and then try and see what the graph is going to look like. So let's pick different amounts for x, and then we'll figure out the cost based on those amounts. It doesn't make sense to look at x less than 0 because we can't use a negative amount of data. So let's start with 0 gigs, 1 gig, maybe 1.5 gigs, 2 gigs, 3 gigs, 4 gigs, maybe 4.5 gigs, and 5 gigs. Now, we know that if x is between 0 and 2, the total cost is $30. So for each of these in the beginning, the total cost will be $30, regardless of how much data we use, up to 2 gigs. But then after that, this is where we're starting to pay for more data, and this is where we have to plug in our values of x to this expression. So I'm going to make a little bit of extra room to show my work. When x is 3, that's going to be 30 plus 5 times 3 minus 2. Well, 3 minus 2 is 1, and 5 times 1 is 5. So that's going to be 30 plus 5, so $35. And then for x equals 4, we've got 30 plus 5 times 4 minus 2. 4 minus 2 is 2. 5 times 2 is 10, so that becomes 30 plus 10, which is 40. If we've got 4.5, that's going to be 30 plus 5 times 4.5 minus 2. 4.5 minus 2 is going to be 2.5. And then 5 times 2.5 is 12.5. So we've got 30 plus 12.5, which is $42.5. And then finally, when we're looking at 5 gigs, we've got 30 plus 5 times 5 minus 2. 5 minus 2 is 3. 5 times 3 is 15. So we've got 30 plus 15, which is $45. Let's sketch a graph of this function now. And I want to point out that we're never going to be dealing with negative values of x. our domain is only going to be positive numbers along with 0. And also the range is never going to be negative because the cost for the cell phone plan is never going to be negative. So all of our points are going to end up being in the first quadrant. Let's make a graph. So we've got our x-axis and then c of x vertically. Notice that I'm not using the typical graphing paper template that we use because the numbers here, the y values are larger than 10. We've got big numbers, so we've got to make our own template on the graph paper. So I'm going to look at 1, 2, 3, 4, 5, 6 on our x-axis. And then the cost goes all the way up to 45. So let's let this be 10, 20, 30, 40, 50, and 60. So vertically, each of these boxes is 5 units, 5, 10, 15, 20, 25, 30. And across, each one is half a unit. So half, 1, 1.5, 2, 2.5, 3, etc. Now let's plot our points. The first one is 0, 30. So that's right there. And we've got 1, 30, 1.5, 30, and 2, 30. And then after that, we've got 3, 35, 4, 40, 4.5, 42.5. 42.5 is halfway between 40 and 45. And then 5, 45. So we can see here that we've got a line segment, a constant function, until we get to 2. And then once we get to 2, we start paying for more data. And so we're moving up in a diagonal line. And so this is the graph of our function c of x. There are several different scenarios in the real world where we don't have a nice equation or a nice formula that gives us our function. Sometimes we'll have different equations based on the input values. We're going to have to separate the domain into multiple parts. And this is just one example of how this works. We're not going to see too many piecewise defined functions over the course of the semester, but we do want to be familiar with them in case we do run into a scenario where something is modeled off of a piecewise defined function.